you see here is the first part of my prototype rocket engine turbopump. Now I know I still haven't even gotten my first rocket engine to work or even done a full test on it, but I figure I'm going to need to know new software in order to make the future pumps, so I'm planning 3 steps ahead. So this will be, I guess, maybe my third size of rocket engine I want to build. So this is for the very large one. And I've realized, actually I've come to accept that Blender 3D just will not work very well for what I want, because it just doesn't work very well for CAD. It works wonderfully for animation and game design and everything, but it just doesn't work too well for this. So I've started using OpenSCAD, or OpenSCAD, whatever you want to call it, and I feel like I've gotten some pretty good results. Now, to be fair, I know a lot of you probably are seeing a lot of issues with this, but to be honest, when I designed this, I hadn't even heard of the program or used any of the CAD software ever. So this is after only 16 hours of experience, so I think that's pretty good. Now, the goal is to eventually take this and then make a plaster cast of it, remove all the air in a vacuum chamber, then basically do lost ABS casting, although I may try lost PLA, I'm not sure. So this would melt away and leave a mold, which then I can cast a metal part. So I can cast a metal part, and then I can actually have that metal part cleaned up on a CNC or a milling machine or whatever I need it on, or a lathe. But I think that would save a lot of engineering, but I could be proven wrong. I want to find out if I try, though. Next time I probably won't print it that way. I will probably add manually add support to the actual model itself like I normally do. And I'm thinking I might be able to get away with printing it sideways. We need a lot less support that way. Also, I could just make it have support in the model itself up to here. And since this is going to be cast, I'm not actually going to be having the weaknesses of these layers themselves. So that is an option, perhaps. We could try that and see which ones handle best. But like this print, this took, let's say 22 hours. So this is 22 hours of printing right here. However, I'm not very certain if I should print the stuff that'll go around it or just machine it, because at this point, maybe just buying a big piece of metal and machining it would be a good idea. I don't know, it's hard to tell. You know, I wonder if I could actually feed these 3D models into something and have it cut out, you know, like subtractive manufacturing. Is that a thing? Because I know additive manufacturing is what I'm mostly knowledgeable of, but I guess subtractive manufacturing, like machine shop work, actually a computer-controlled device maybe could actually take a 3D model, and as long as you give it the right sized material so it knows it has whatever size block of metal it's dealing with, then maybe it could actually go through and do all that for you. I don't know. And if I did that, then I wouldn't have to worry so much about the consistency, because if I'm going to cast metal with the mold I make from this, then I do have to worry a lot because this thing is going to be spinning at an extremely high frequency, or RPM, sorry. So this is not the main turbo pump impeller. This is the screw that goes on top of the impeller, which basically helps, at least from what I understand, it helps push the fuel or oxidizer down and into the impeller, so there's not like a cavitation, that's the term, cavitation. And also I believe this helps increase the pressure, so, you know, perhaps I could actually do tests just with a screw thing. I don't know, it's an idea. So I've been thinking about it, and at least for this part, if I bought like an 8 centimeter wide stainless steel bar, because I imagine stainless steel would be good for these, If I was going to cast this, which I hope to, then I'll use aluminum because it'll be easier to cast and it'll be lighter. But we'll see how that works. I think aluminum should be fine. But you can get, like this is, oh, let's see, 60 millimeters tall. You can buy a 1 foot section of a bar that'd be good for this for like $180. So I could maybe get 4 of these out of that. That's quite a bit of money though. Now I really love how this came out because it gets thicker the closer you get to the main cylinder. And I intentionally made this so this hole is a bit smaller, so it's actually, I believe, 8 millimeters wide, or maybe it's 10, I'm not sure. Either way, I made it to where I can drill it out to make it exactly 1 centimeter wide. I believe that'd be a nice shaft size. But basically this entire thing is just made of this shape. Actually no, it's this completed. I have this cut in because otherwise this came out to a paper thin edge that came out to about here, and that paper thin edge would break, so I cut into that and made it actually a hard angle there. I think that'd be better instead of having that edge that could chip. But basically this entire thing is just like this. Well, actually it's a big sphere and a small sphere, and this entire, the model itself is that big. It continues quite a bit, but I cut off the outside, and so it's just a series of those plates stacked on top of each other. And so because of that, because this one's bigger, this side's bigger than that side, then we actually get a growing effect where this is thicker near the middle and thinner at the edges, which I think is probably a good idea. Now I could also make it to where this is higher or lower, so that can change the pitch of them, which I think, so this is the idea, to have it spinning this way and pulling it down. So I might want to have these pitched down so they kind of cup it near the middle and not pushing it out near the edges where there could be some leakage. Oh, and yes, that's the washing machine in the background. I'm in the basement after all. So I was thinking about it, and this part would be the most difficult to machine but costs the least if I bought it with a preformed billet or ingot or just a rod of metal this width and however long I might need. So there's a lot of warping on this, and especially on that part. So you can see that this entire piece right here has curved in. Now I totally forgot that I used to have these problems all the time back when I worked at Apple and when I did 3D printing for a career basically. So the fix for this, I believe, is just to put it on stilts up 1 centimeter. I mean, that kind of works. Now, this one is pretty much ruined up to like the first half turn. So, what I'll do is I'll just use this one as a 2-loop one. So I'll cast this one. I can test, like get more familiar with casting these. Then I can actually cut it along here and cut it there. So basically it's just one loop missing. So imagine it's like that instead. And then I can use this one to be the high RPM test. So that's good. I'm not going to bother testing with the plastic though, because I think it would just shatter. And I'm not going to be using plastic for the pump anyway, so maybe that'd be a better idea. Go ahead and, this would be like a practice run for casting. And then the next one, I can actually do better. So the next one, I believe I should do sideways. I'll have my handmade support for it, so it holds it up. And I also made it so it holds it up like 20 millimeters off of the plate. That way any warping doesn't affect this. Now I do worry that going like this, any warping in the layers would actually affect this. Although I guess this way it also affected it also, so it would save a lot of material and time to go this way though, so I think that's probably best. It's a real shame that there's such a steep angle on here, because, you know, it is just stacking layers of those on top of each other. So if it wasn't such a steep angle into the edges, then I actually could just 3D print it like this without any support. But we all know how that would go. That would end up being a fair amount of warping. Another thing to keep in mind is that I forgot it until just now. Castings, I believe, shrink. So I'll have to make this 10% bigger, which I was going to make it like 5 or 10% bigger already, because my plan is to make these oversized, at least wider. The middle part will be how I want it to be, but the blades will go out further. That way whenever I'm done and I have the metal version of this, I can actually take it, I can sand down the fins to make sure they're nice and smooth, but then I can put it on a lathe, and I can have the lathe tune the edges to where they're all super symmetrical, and just they can have a nice butting up, a nice connection, or not quite a connection, but they can be very well sealed against the chamber that they will be in, the ducting, if you will. Now the stuff that goes around this, now this is just going to be a tube, but underneath this will have to be like a donut shape that will catch the gases or the fluids that are whipped into there. And I think that the outer shell of that could actually, I could probably machine that. However, getting metal in that big of a lump, because I'll probably need a piece of metal like that big and it'll weigh a ton, that would be too expensive. So like this is cheaper to buy, the stock for subtractive manufacturing, but actually manufacturing it seems a bit way too complicated. Although I'd like your guys' opinion on how you think that could be done. Like, theoretically, I could maybe have where I make a machine that turns it, and you have what's it called, an end mill, and it cuts through. But I don't think I would get the nice, like, triangle shape, or triangle profile of these, because these things are actually pretty strong, which I'm really happy about. I'm very, very happy that even this plastic part is just so strong. It really helps having that triangle shape on there. So yeah, I'll change the design, which making this bigger while not actually affecting the rest of this will be really easy. And I'll see about putting it on the side, but I can also see about making a casting, and I'll have to get my furnace working because I don't actually have a metal casting furnace. Now here's another idea. So a lot of people actually cast metal by heating up the metal in a crucible. Then they take the metal, and they have the mold that was made around this, which this is now vacant. It's for the metal to come into. And I imagine I have a lot of problems of the metal not coming out all the way to the edges. So what I'm thinking to do is, why not use the mold as the crucible? That's an idea. And with aluminium, you're not talking about steel level temperatures, we're talking just aluminium. I don't think I can really do stainless steel because I do not have a nice supply of stainless steel. Well, not a nice supply of similar stainless steel, and plus I believe the temperature is a lot higher on that. But I'm thinking, what if I were to make a mold out of this? So it's a plaster mold, and I make it, I let it set in a vacuum chamber so it pulls all the air out, and then I bake it so there's absolutely no moisture in there, and then I have the metal on the top. So I put it into an oven, a forge, most likely electric because that would be very nice, and I heat the entire thing up, and the metal slowly melts and falls down into the forge, into the mold. In the forge it melts and goes into the mold. There we go. And I could even have it to where it has to go through like a channel in order to like not let the slag come through. That is an option also. Although what I'm thinking is this. The metal that I put in there, because I have several blocks of like relatively nice aluminium, and I could actually clean it with like an acid or something. And then I'm thinking, cast metal has air bubbles in it. What if I were to make this entire thing happen in a vacuum chamber, so there is no air? And then right before it would cool, I can let like nitrogen or something back into the system, and that way the metal, like any vapor bubbles that are in there, contract. So that's an option. I don't know. I can experiment with that. Although I think that if I just make sure to have like a good casting, it probably could actually have a high amount of rotation on it. I don't know. I'm going to get a couple of turbochargers, and we can look at the castings on the impellers on those, and the turbochargers will most likely be used for the next rocket engine experiments. So this is for down the line, and since I'm going pretty slow with this will probably give me several years to work on this. However, I am also thinking about starting a rocket club in the area, and I may have gotten access to the old machine shop at one of the local schools, which has about 12 lathes and milling machines and CNC machines. So if I can do that, then I might be in business. And I might be able to get funding if it's going to be like a school project. I can like help. Well, I wouldn't be a teacher, but I would be a team leader, I guess. Because it's not that I know how to do all this. It would be like the Montgomery County Rocketry Experimentation Club or something like that. And I might be able to get some support from the school and stuff like that, and some other people that have a lot of funding in the area. So that'd be kind of cool, because me and John, he owns the Red Rooster Inn, we're actually working on making a makerspace, a tech shop, and it's looking like we've gotten a little bit of funding for that, so that's kind of cool. That's the main reason why we have access. We might have access to the machine shop, and so if we get that, if we have the makerspace, which I'll probably be spending some time there, and might as well also have a rocket team, and maybe I can have like a couple extra helping hands to do this, and maybe a little bit of funding. That'd be kind of cool. I'm not sure if that'll work, but we'll see. And I figure I can probably find someone else that has an even more remote area of land to actually do bigger rocket tests. That'd be kind of cool. But that's just my ideas. I think that additive manufacturing is a very good way to go with this. And I think I just need to refine my process to make this. And then I can focus on the actual casting part. I think that subtractive manufacturing might be the answer for making the parts that go around this, because with that I could probably just spin that on a big lathe, and well, it's hard to tell. So the simpler things like the shroud that goes around it, I think it'd be better to start with a big chunk of metal, like a big cylinder or something like that. Or not cylinder, a big cylinder, because a cylinder doesn't necessarily have a hole in it. So that's just an idea. I think I would like to hear what you guys' opinions are on this. Whatever, it's late. And what methods I should use for what parts. For instance, for the generator, I'm going to copy a little bit of the, I guess it's kind of like the V2 rocket turbines. And I'm going to have this part right here basically copied into my design, and that will be the generator. That will take the combusted fuel from the smaller combustion chamber and spin the pumps for the bigger combustion chamber. Well, it'll be the gas generator cycle, but you know, whatever. So yeah, I don't really want to talk about OpenSCAD or OpenSCAD too much right now, because I am literally a noob at it, but I'm learning quite a bit, and I think it's a good idea to put this video on Patreon, because in a month I'll probably know a lot more and can actually do a video about OpenSCAD. So yeah, so that was my first day of OpenSCAD, and it's going pretty well. Now I'm working on the part that goes underneath it. Don't know. Well, that's pretty much it. I hope you guys enjoyed this video, and thank you very much for watching. See ya!